Hello everyone, I hope you all are good and you all are practicing questions. In this video, we are going to do a series of two questions and both has to do with what is the force getting exerted by radiation. So since we are going to talk about force exerted by light, we will be talking about particle nature of light because we need to deal with momentum, we need to deal with change in momentum. So we will be dealing with particle nature of light here. So क्वेश्चन में ये कह रहा है कि parallel beams of light are there and this is getting incident on a surface which has an area of A and intensity of light beam is I. ठीक है, we have to calculate force in the first case when the surface is perfectly absorbing and light beam is incident normally on it. So let us first of all understand what is this intensity. So intensity is nothing but energy falling पर यूनिट एरिया पर यूनिट टाइम. सो एनर्जी पर यूनिट टाइम को आप क्या कह सकते हो? पावर. सो पावर पर यूनिट एरिया, इसको आप कह सकते हो इंटेंसिटी. ठीक है, एंड इफ इंटेंसिटी इज गिवन, हाउ यू कैन कैलकुलेट पावर? सो फॉर दैट ऑल्सो यू शुड बी वेरी क्लियर. पावर को हम लिखते हैं डॉट प्रोडक्ट ऑफ इंटेंसिटी एंड एरिया वेक्टर. ठीक है, सो बेसिकली if light is falling like this and clearly you can see this is the area and normal to the area will be what line? It will be this line, right? Normal to the area. So with normal to the area, this light is making certain angle and let's say it is making an angle theta. So what is the amount of light falling or amount of energy falling per second? So amount of energy falling per second means I'm talking about power, and that you will be calculating by intensity, intensity into area into cos theta, because theta is the angle between area vector and light direction. ठीक है, so this is your what? Theta here, and that is why your cos theta term. So before solving all the questions, we should be aware of this thing. Now let's start with this one. The surface is perfectly absorbing. अब देखो यहाँ पे होगा क्या? This is the surface, right? And upon this, light is falling normally. So light is coming like this and it is getting absorbed. So treat this light uh, as made of particles. So it is made of so many number of photons. Okay? And when basically light is striking the surface, we can understand like photon is striking the surface. And upon a striking, photon is getting absorbed. Simple. Okay? So it is simply like कि you are striking a wall with the ball, and initially just before striking the wall, this ball had some momentum, and after collision that ball is simply disappearing. ठीक है, so simply its momentum is becoming zero, it is no longer in the scene, it is getting eaten up by the wall. Simple है, ठीक है. So initial momentum is something, final momentum is zero. So initial momentum क्या होगा? If the wavelength of light is lambda, then you must be having idea of कि formula है तुम्हारा. Momentum क्या होगा तुम्हारा? Momentum को भी P से indicate करूँ. Okay, let's talk about momentum like this. So momentum is equal to how much? H by lambda, where lambda is the wavelength of light. So initial momentum is this. What will be the final momentum? That is zero. What is the change in momentum? So that is minus H by lambda, because we have just now written Pi is equal to this, Pf is equal to this, because it is getting completely absorbed. Done it? So change in momentum is this. Modulus of this will become how much? H by lambda. So somehow if we know what is the rate of change of momentum, we will be able to calculate force. Now how we can get around calculating rate of change of momentum? Simple है. आपको ये देखो, यहाँ पे single photon नहीं strike कर रहा. There are so many number of photons striking. So somehow if we are able to calculate how many photons will strike per unit time upon this area A, then if we know n number of photons striking per unit time upon this area, then all this n number of photons will undergo this amount of momentum change. So if you multiply n with h by lambda, this n is what? Number of photons striking per second. So there is a time factor coming here, and this is your change in momentum. So basically this will become total change in momentum happening per unit time. डन है. सो वी ओनली नीड टू कैलकुलेट व्हाट, वी नीड टू कैलकुलेट एन. तो चलो एन को निकालते हैं. एन कैसे निकाल सकते हैं? सो नंबर ऑफ फोटोन विल बी इक्वल टू energy of light falling per second, that is your I into A here, because here light is incident normally. So angle between incident light direction and normal to the surface is 0 degree, right? So this is IA. So this is energy incident per second, and this will have how many number of photons? कितना होगा बताओ? One photon will have an energy of how much? hc by lambda. This is the energy of one photon. ठीक है? So energy of single photon is this. How many photons will be contained in this much energy? So इसको आप hc by lambda से divide कर दो. Just a unitary method, that hc by lambda has one photon, then 1 joule will have how many number of photon? 1 by hc by lambda. So this much joule, that is IA, will have how many number of photon? This much. So that is what I have written here. ठीक है? So अब आप इसको solve करो. IA hc by lambda, it is this one. ठीक है? So rate of change of momentum, आप क्या लिखोगे? IA lambda by hc into how much? Into delta p, and delta p तुम्हारा क्या आया था? h by lambda. So this is h by lambda, and this h by lambda will get cancelled, and you are left with what? I by c. So this is going to be the answer. This is going to be the force getting exerted on the surface because of light incident normal onto the surface, and light is getting completely absorbed, yani ki coefficient of absorption is 1, reflection is not happening, so this is 0. ठीक है? So this is I mean this is what is A, what is R. So if you are talking about, जैसे suppose कर लो Q amount of light is falling per second. So total light falling is Q amount of light. Then let's say QA is getting absorbed and QR is getting reflected. So A is equal to QA by Q, and R is equal to QR by Q. But here QA is equal to Q because all are getting absorbed. A is 1 and QR is 0, R is 0. ठीक है? चलो, now let's talk about the second case. Surface is perfectly reflecting and light beam is incident normally, is incident normally. ठीक है? अब देखो इसको आप कैसे डील करोगे? So we just need to go around with this again in the same way. So let's start with this one. So surface is perfectly reflecting and still light is normally incident on the surface. So देखो light कुछ ऐसे incident हो रहा है, and if light is normally incident on it, it will get reflected along the same line, है ना? Because I is equal to 0, then R will also be 0. ठीक है? So this is happening. Now initial momentum आप क्या लिखोगे? Initial momentum is h by lambda. What is the final momentum? That is minus h by lambda. What is the change in momentum? That is minus 2h by lambda. What is the modulus of this change in momentum? So you will be telling 2h by lambda. Now what is the number of photon getting incident per unit time? So overall rate of change of momentum happening upon the area A will be equal to how much? So that will be equal to, आपने अभी अभी निकाला था ना this thing. So this is equal to, n is equal to how much? IA lambda by hc. So IA lambda by hc into 2h by lambda. So यहाँ से तुम्हारा lambda, lambda will get cut, h will get cut. So this is 2 times of the previous case, right? So this thing, and from where 2 factor is coming up? This is coming up from this reflection thing. Done है? So this is over. अब देखो हमारे पास next क्या है? Next is the surface is perfectly absorbing and the light beam is incident at an angle of incidence theta. So अब देखो अब क्या है? अब light is falling like this. So normal to the surface is making an angle theta with the direction of light. So we need to carefully now define energy of light falling per second. So that will become how much? IA cos theta. ठीक है? So this thing we have to be careful with this. Now along this line, along this direction, light is falling and it is getting completely absorbed. डन है? So यहाँ पे photons कुछ ऐसे आ रहा है and it is getting absorbed. So you just treat it like I mean collision happening of photon with the surface along this line, and then along this line this photon is getting absorbed. So why this photon is getting absorbed. Just before striking, it has certain momentum that is equal to h by lambda. And after collision, it is not left with any momentum. So in short term, you can say कि इसकी velocity zero हो गई है, कुछ भी नहीं है इसके पास. ठीक है? So in that case, you can say upon this, initial momentum was in this direction. During collision, force must have acted in this direction. And that force made its momentum equal to zero. ठीक है? So we can talk like this. Over. So force in this case will act along which line? It will act along this line upon the photon. Upon the photon. So upon the surface, force will act in which sense? In this sense. अकॉर्डिंग टू न्यूटन्स थर्ड लॉ, राइट? बिकॉज कोलिजन का फोर्स क्यों लगता है? दो बॉडीज के बीच में इंटरैक्शन की वजह से, एंड दैट इज बेसिकली इंटरैक्शन फोर्स. सो इफ इट इज एक्टिंग ऑन द फोटोन, इट इज ऑल्सो एक्टिंग ऑन द सर्फेस, एंड बोथ विल बी इक्वल एंड ऑपोजिट, राइट? सो इट इज लाइक दिस. डन है? इस केस में अगर आपसे कोई पूछता है कि फोर्स किस डायरेक्शन में लगेगा ऑन द सर्फेस, सो यू विल टेल कि इन दिस डायरेक्शन, along the direction of incident light. Simple. So this is the case. अब आप इनिशियल मोमेंटम की बात करो. सो इनिशियल मोमेंटम इज हाउ मच? h by lambda. What is going to be the final momentum? h by lambda along this direction, right? So pf is equal to 0. And if you know the basics of this collision thing, you know line of impact. So here line of impact is this, right? Because along this line force is acting. This is line of impact. Force during collision acts along this line. So this is line of impact, right? And along line of impact only we conserve momentum. So along line of impact, initial momentum is h by lambda, final is 0. Delta p modulus, if I calculate, this is h by lambda. डन है? सो व्हाट विल बी द फोर्स एक्टेड? सो उसके लिए आप नंबर ऑफ फोटोन निकालोगे स्ट्राइकिंग पर सेकेंड, एंड फॉर दैट यू विल बी डूइंग आई ए कॉस थीटा डिवाइडेड बाई एच सी बाई लैम्डा. So this is this. Now what will be the force? N into delta P. So force को आप लिख लो, N क्या है? I A cos theta divided by hc by lambda, and this into change in momentum, that is h by lambda. So this will get cut. So I A by C cos theta. So फर्स्ट क्वेश्चन को आप याद करो. फर्स्ट पे आंसर क्या आया था? I A by C. This was also the case of absorption, right? And this is also the case of absorption, but here angle, I mean light is not normally incident, it is making an angle theta with the normal, and because of that theta factor coming in, this cos theta term is coming. ये कहाँ से आया था? This is coming from calculation of energy of light falling per second. ठीक है? So from here you should be clear about this. Okay? Now let's talk about force. The surface is perfectly reflecting and the light beam is incident at an angle of incidence theta. So now also again this light is again in this case also falling like this, but it is now getting perfectly reflected. So in this case also power, that is energy falling per second, will be this only, and number of photon falling per second will be this only. We need to now talk about momentum thing. So momentum thing की आप बात करो, क्या होगा बताओ? Initial momentum तो same as before होगा, but now line of impact is going to change because here light is incident at this angle, and it is said that light is getting perfectly reflected. So it will get reflected like this. Done it? So initially, if you talk about single photon, it has struck the surface in this way, and it is going away in this way. सो लाइन ऑफ इम्पैक्ट इज अलोंग विच लाइन? आप याद करो कि वॉल पे जब आपने बॉल को कुछ ऐसे फेंका था, एंड इफ बॉल इज कमिंग अलोंग दिस लाइन, ठीक है? क्योंकि नॉर्मली जब हम क्लासिकल फिजिक्स, जो भी हम नॉर्मल फिजिक्स पढ़ते हैं ना, जहाँ पे वी आर टॉकिंग अबाउट मैक्रोस्कोपिक ऑब्जेक्ट लाइक बॉल एंड एवरीथिंग, सो इन दैट केस अब्जॉर्प्शन वाला थिंग नहीं हो सकता. वॉल कैन नॉट ईट बॉल, राइट? सो वो केस वहां होता नहीं है, एंड इन दैट केस force during collision always acts normal to the surface. है ना? I have talked about this thing कि if collision happens between a smaller body and giant body, in that case line of impact will be normal to the surface of the giant body, right? So here line of impact will be perpendicular to this thing. Done है? Here also line of impact will be perpendicular to this thing. And if you want to see it, तो आपको पता होगा when ball is coming like this, it has momentum in two direction, in this and in this direction. After collision, it has momentum in this direction and in this direction. Sorry, after collision, the ball has velocity in this direction. So it has momentum in this direction and this direction. So momentum of this direction stayed the same. Momentum in this direction changed in this direction. And that is why force acts along this direction. Okay, but we don't need to go into detail of that concept because we have done it already in the collision concept. We have dealt with it so much. Okay, so something like this is happening here also. I mean, line of impact is this one, and if this is the line of impact, then what is going to happen? Along this line force will act. ठीक है, so प्रीवियस केस में absorption के केस में मैंने क्या कहा, यहाँ पे force on the surface was acting along this line, and in the case of complete reflection, force will act on the surface along this normal line. ठीक है, this you have to remember. Now let's talk about initial momentum. So that is h by lambda for single photon, and final momentum along the line of impact लेकिन निकालना पड़ेगा. ठीक है, so final momentum along this line is h by lambda only. ठीक है, but since line of impact is this, we will conserve momentum along the line of impact. That is the rule of collision. So initial momentum आप क्या लिखोगे along the line of impact? This is theta. So h by lambda cos theta. ठीक है, फाइनल मोमेंटम आप क्या लिखोगे? माइनस एच बाय लैम्डा कॉस थीटा. डन है, बिकॉज दिस इज ऑल्सो थीटा, एंड दैट इज वाई आई सेड कि इस डायरेक्शन का मोमेंटम चेंज नहीं हो रहा. इट मीन्स इन दिस डायरेक्शन देयर इज नो फोर्स एक्टिंग, ऑल फोर्सेस एक्टिंग अलोंग नॉर्मल टू द सर्फेस. ठीक है, सो डेल्टा पी, क्योंकि इस डायरेक्शन की मोमेंटम की अगर आप बात करो तो एच बाई लैम्डा साइन थीटा इनिशियली, एच बाई लैम्डा साइन थीटा फाइनली. सो इफ मोमेंटम इज नॉट चेंजिंग इन दिस डायरेक्शन, it means no force is acting in this direction, and momentum of this direction has changed. Initially it is downward, finally it is upward, so it has completely got reversed. Force is acting along this line. ठीक है, so change in momentum आप क्या लिखोगे? मॉड्यूलस अगर आप लिखो, you will be writing 2h by lambda cos theta. Now what will be the rate of change of momentum? So delta p by delta t, n, that is your ia cos theta divided by hc by lambda, है ना, and this into this thing delta p, that is 2h by lambda cos theta. So h by lambda को आप कट कर दो. ठीक है, and this 2 term is coming, also extra cos theta is coming. ठीक है, so 2ia by c cos square theta. ठीक है, so let us compare this result with the second one. So second one में how much you got something 2ia by c when the light was incident normally and it was getting completely reflected. Here cos square theta term is coming, right? And why this cos square theta term? First cos theta came from here, and second one from the conservation of moment. So you should be clear of this thing. Now let us solve one question based on this. So there is a horizontal beam of light that is incident on a plane mirror inclined at an angle of 45 degree. So it is like this. The percentage of light energy reflected from the mirror is 80%. Find the direction in which mirror will experience force due to incident light. So 80% is getting reflected, 20% will get absorbed. Let us say n number of photons are striking per second. Because here we simply have to talk about the direction of force. Done hai? So I mean, there is nothing getting talked about intensity of light and power. So let's talk about n number of photons striking per second. So this is number of photon striking onto the mirror per second. ठीक है, so this is this. अब आप देखो 80% of it will get reflected. So 0.8 n photon will get what? It will get reflected. And what will happen with the rest amount? That is 0.2 n will get what? Absorbed. So now let's talk about this force due to reflection and absorption. So सबसे पहले absorption की बात कर लेते हैं. If light is coming like this, it will get absorbed along this direction itself. ठीक है? So whatever photons were falling along this direction is getting absorbed. So its initial momentum is along the direction of incident light, that is h by lambda, and final momentum is 0. This is initial momentum, and final momentum will become 0. And just now we have discussed, in case of absorption, force will act onto the mirror in the direction of incident light. So because of this 0.2 n number of photons striking per second getting absorbed, force on this mirror will act in this direction. ठीक है, and this absorption force value will be equal to how much? So 0.2 n is the number of photons striking per second, and this n2 change in momentum, and this is what overall change in momentum happening per second. So this is the amount of force acting because of absorption. Done it? Now we need to calculate what is the force acting because of reflection. So reflection की बात कर लो. This is the incident light. You will draw normal onto the mirror. So mirror पे आप normal बना लो. And this angle will be how much? You can see here. This is 45 degree. And this is perpendicular to the mirror. Done है? And this is again horizontal. So I mean this angle it will be also 45 degrees. So this angle also has to be 45 degree, because this is the angle between uh, mirror and the vertical line, and this is perpendicular to vertical line, this is perpendicular to mirror, so angle between these two will also the same, that is 45 degree, and that is coming from, if angle between two line is theta, angle between their perpendiculars is also theta. ठीक है, so from there we are getting this one. अब आप इसको solve करो, incident light is this one, reflected light will be along this line, ठीक है, also making an angle 45 degree. Then so reflected light will definitely become vertical after reflection. And just now we have discussed, in the case of reflection, force on the surface will act along the normal. Done it? So force on the surface in this case will act along this direction, which is normal to the mirror. This is because of reflection. Now what will be this value? So that will be equal to, I mean, what is this initial momentum? So initial momentum you are going to write along the normal, because this is the line of impact, and along line of impact we conserve momentum. So h by lambda cos 45, that is 1 by root 2. Final momentum is minus h by lambda 1 by root 2. Change in momentum delta p modulus agar aap likho, then this will become 2 into this one, okay? So that will be root 2 h by lambda. So this is this. Now what will be the force acting? So this force acting will be root 2 h by lambda into 0.8 n, because this is the number of photons striking per second. So this we are getting. अब देखो ये force हमें पता है, and the another force is what? Another force is acting because of absorption, and that is equal to Fa, and Fa value is equal to how much? That is your h by lambda 0.2 Newton. ठीक है, so this is, sorry, n था ना ये, this is n Newton, again that will stand as n, but let's call it this unit, and this unit. ठीक है, what we were required to calculate, find the direction in which mirror will experience force due to incident light. So overall किस direction में इसे force मिलेगा, that will be resultant of this one. Or you can do one thing, you can break this FR into vertical and horizontal, and then calculate the direction. So overall FA is in this direction, and a component of FR will come in this direction. How much? So in this direction total force will be FR cos 45, right? So FR cos 45, and in this direction it will be how much? It will be Fr sine 45, that is Fr sine theta, because in this direction Fa will have no component, right? So net force will be in which direction? It will make this angle with the direction of incident light, because along the direction of incident light is Fa, so this is the direction of incident light, right? So this will be the overall angle getting made. अब देखो एफ आर साइन थीटा क्या होगा? सो एफ आर साइन थीटा, थीटा इज हाउ मच? 45. सो 1 बाई रूट 2 करोगे, दिस विल बिकम एफ आर साइन थीटा, अगर आप निकालो तो एफ आर साइन थीटा विल बी इक्वल टू एफ आर इज हाउ मच? रूट 2 एच बाई लैम्डा. सो रूट 2 एच बाई लैम्डा इंटू 0.8 into 1 by root 2. So this will become nothing but 0.8 h by lambda. ठीक है, and fr cos theta, again same thing, that will be 0.8 h by lambda. So in this direction it is 0.2 h by lambda plus 0.8 h by lambda, and in this direction it is how much? 0.8 h by lambda. So this will become how much? This will make how much angle? Let's call it theta. So tan theta is equal to 0.8 h by lambda divided by this thing, and that is equal to h by lambda. So this will get cancelled. Tan theta is how much? 0.8. You can break it like this. So this is your 4 by 5. Okay? So theta is nothing but tan inverse of 4 by 5. Done it? And this will be how much? I mean, this is your I mean sine theta by cos theta. So this is 53 degree, right? So this is your 53 degree. Anyway, that will be provided with in your question in the competitive exam, so you don't need to worry about that thing. Okay. So I hope you have got all the concepts related with this one, and I hope everything is clear. But if you have doubt anywhere in the question, you can always let me know in the comment section. Thank you. Take care of yourself and keep on solving more number of questions. Bye bye. Take care.